Hello everyone and welcome to my YouTube channel. In today's video we are going to build a PyTorch trainer from scratch. There is a lot of code floating around on the internet and most of the time you don't need all that. You need something which is customizable and still Pythonic. If some trainer or wrapper is making your code ugly and non-Pythonic, you must stop using it. As you can see in the background, there is a GitHub repo and it's called Thaze, which means sharp or active. And this is a trainer that I have built. The idea comes from one of my old repositories called WTFML. And a lot of ideas have been borrowed from the most amazing machine learning library, scikit-learn, and the most amazing, most famous deep learning library called Keras. In this video, you will learn how to build a PyTorch trainer, specifically Thaze. You can also go around and you can do a pip install Thaze if you want, and you can start using the library. So the idea around what I've built here is very simple. I have to keep things as simple as possible. There is no need to complicate stuff when it's not required. Make it as customizable as possible. Clean code, it's very important, and it can be used for faster prototyping, and it's always production ready. You are not leaving the PyTorch ecosystem at all. There are no dependencies. So it's as close to PyTorch as it can be. So to get started, let's go to our code server environment and start coding it, and then only you will learn how it is built. So let's get started. So now we are in our code server environment, and now we can start building the trainer. So the only things that you need to remember is what are you simplifying. So PyTorch has a lot of things floating around. So you have to simplify a lot of things. One of the major things is the loop, the training loop. So let's say the training loop. Let's write down a few things. Then you also have you can have different types of optimizers. You can have different type of scheduler. So you need to take care of that. And what you want to do is you want to put everything in the model. So like if you have seen how Keras trains the model, it just calls model.fit. So we don't have to call another class or another function and another function after that to just train the model. We can do it in one go, and that's what our goal is. So we need to take care of the model. So one of the most basic things in Python, not basic but advanced, is class inheritance. So what it does is you inherit from some other class, and then this class will have all properties of the other class, the parent class, and its own properties. So let's import nn.module. So we can do import torch.nn as nn, and here we can write nn.module. Okay, and let's write the init function. Init, and here we have self. We can also write some arguments if some arguments need to be provided. So args or keyword arguments if required. You can also skip this step. So we got these, and now what we do is we write super, and then we do dot underscore init, and then provide these arguments and keyword arguments to the parent init, in case you want to do that. So this is the way I would do. But you can totally skip this if you want to. So now there are a few more things. So we had optimizer. So let's define a simple optimizer variable and set it to none. Similarly, we can have a scheduler, set it to none. So we got the optimizer, we got the scheduler. maybe we will have few more things. Maybe train loader. So that is a data loader that you have. Set it to none. We can also get valid loader for your validation stuff. Set it none. And then go to the next step. So what does the next step do? So then there are many things that you can do. We will break it down into different parts so that it's much easy to understand. So we do fit and self. So this is the function that you will call model.fit. And here, what do you want to provide? So what we are doing is we are building a trainer that requires only two things: your dataset class, the PyTorch dataset class, and model class. That's it. So when you're saying model, okay, then dot fit, it should take train underscore dataset. So I will leave the validation as an exercise for you guys. Let's just do train. So train underscore dataset, then it will probably need some batch size. What else? What else do you think it might need? Let's keep it like this. And epoch, obviously, that's important. Epochs. So we got a few variables in, and now we can write our loop. So here you see I have taken train dataset. You can also take train loader if you want, but what I'm going to do is I'm going to create the loader inside the fit function, so you don't have to go and create the train loader. So you can just do from the dataset, and it simplifies your code. So I will say I had already defined train dot train loader, self dot train loader. So it's defined here. So what I'm going to say, if self dot train loader is none, then create the train loader. Then self dot train underscore loader is equal to, so what was it? Let me import torch, and here we have torch dot nn dot utils dot data loader, torch dot nn dot utils, no, sorry, torch dot utils dot data loader, but there was a class. Okay, so we got a data loader. That data loader takes train dataset. It can also take batch size, which you have batch size, and what else? I think that's it, right? Shuffle, probably shuffle to true, because it's our training set. So we did that, and then what we do is we write the training loop. So I would say for underscore and range epochs, do some training. So train underscore loss is equal to self dot train one epoch, and train one epoch takes the train underscore loader as an argument. What you can also add here is device, and you can check which device is the model on. So if next self dot parameters and then dot device, so this will give you what device the model is on. If this is not equal to device that you have provided, then self dot device self dot to device. So you must have seen that. So you always do some model.toDevice. So now we are doing just self.toDevice because we have inherited from nn.module. So we have everything that it has, and model is a part of it. So we can just do .to, self.to. So we got self.train1 epoch that takes the data loader. Doesn't need to take anything else. Now it's totally up to us. Maybe we can provide device here, or if we have provided device here, then we need to create another variable called self.device, and we need to make sure that self.device and this device is the same. But for simplicity, what I'm going to do is I'm just going to say device. Okay, so now our fit function is done, except for the fact that it's not going to work. And this should not be train loader, should be self.train loader. Okay. And now we write another function, train1 epoch self, and this takes self and dataset and device. Now it has taken these three things, and you write the training loop. So the first thing that you do is you put your model in the train mode, and that is nothing but self.train. And then you go over all the items in your dataset. Let's not call it dataset, let's call it data loader. So I can just say for data in data loader, do the training. So there are a few things now. So let's say our model returns the forward function of the model doesn't just return output, but it returns output and loss and some other things. So you can make it return whatever you want. So right now, let's say it returns output and loss. So now I create another function, train1 step. Okay, why am I creating those functions? I will tell you soon. Awesome. So now we got our data loader, and using this data loader, we have our loss coming from train1 step, and train1 step should again take some arguments. So it takes data and device. So data is like one sample. Sorry, not one sample, but one batch, one step. Okay, so we got that, and now we do loss dot backward and everything else that you want to do. We also have the scheduler, so you also need to take care of that. Or let's not do the backward here. We will do it inside train1 step. So it returns some loss, and you can say, okay, temp epoch loss equal to 0, and here epoch underscore loss plus equal to loss. Okay, and then you return epoch loss divided by length of data loader. Okay, so you return average loss. So I'm not sure if it can be done like this, or maybe data loader dot so whatever the number of batches in data loader are, so you just need to take care of that. I think you can figure that out. I don't remember. So we got that, and then you return this. So now you got your train1 epoch function. So but you can see, like, we define one train1 step function. So we take this and we write our one batch of training here. So def train one step. So now what it does is, first of all, it will zero grad the optimizer. So self.optimizer.zeroGrad. And see, we still have to define optimizer and scheduler. So let's wait for it. And then what you can do is very simple. You can do for k, v, key and value in data.items. And you can put all the items on device. So you can say data k equal to v dot to device. So you don't have to take care of putting them on the same device individually. So we got that. Now we calculate loss, and let's say our model forward returns something and loss. Something is output and loss, and we just do self 2 asterisks and data. So we just do a forward pass. And then what we can do is we can do loss.backward like we usually do, and self.optimizer.step. So now one thing here that you need to keep in mind, we can also parameterize that, is you can also step the scheduler after one batch of training or after one epoch of training. So here we are just going to hard code it, but we can also make it a parameter, and then you return loss. Okay, so I think everything is done. So you got one step, and now you need optimizer and scheduler. So we are not going to do anything about it. Like, very simple. So let's write a function, fetch optimizer, self args and keyword arguments, and return. So this is just a function that can be replaced by you. Scheduler. Okay, one more thing that we forgot, and that's very important, is the forward function itself. So the same forward function that you have. So what I'm going to do is we provide some args, keyword arguments, and just call super. So same function forward from your parent, args and keyword arguments. Okay, looks good. So now you got everything. So you got your new module class, which has a forward function. It has a fetch optimizer, fetch scheduler, train one step, train one epoch, the fit function. So it has everything. So now we can write, let's say we create this file and we just import it. So we write our new model, my model, and now it inherits from the model class that you have written. So you just do super dot init. So you call the init function of your parent, and here you do the same thing that you would always do. So here you can have anything. Let's say you have number of classes, and here you define your network, define network layers, and then whatever self.out is nn.linear if you have, and something, I don't know, 128, let's say, n number of classes. So this is also your fully flexible as it used to be, and you define forward function. So now when you define forward function, it should take a few more arguments than normal. So it should take inputs or features, let's say features, and it should also take targets, and we can always make it none by default. And then you run your network, you say, okay, this is self dot something that you have defined inside the layers, forward, and then again a x, you do something whatever you want to do, and then you calculate a loss. So you can calculate loss by just writing a function here. Loss takes self output targets, outputs and targets, and you say if targets is none, return none, and otherwise return nn dot any loss that you want. You can customize it as you like. Outputs targets. Okay, so now you have any kind of loss you want. And why we did this? Let's say you're running your model for prediction, you don't have the targets, but you don't have to change any code, and it's not going to crash. So you calculate the loss, self.loss, and here we had, let's say we had output out equal to something something something. So you do out comma targets, and you return out and loss, and that's how you do it. So but we still haven't defined a few things like scheduler. So you can define fetch scheduler if you want to have any, and this takes self, and let's say scheduler torch dot optim dot lr scheduler, and anything you want, step lr, let's say, and it takes a optimizer parameter. So you know, like, your optimizer is nothing but self dot optimizer, and return scheduler. Let's change the name sch. And similarly you have fetch optimizer self. Now optimizer can take some model params or all model parameters. So all your parameters are defined by params equal to self dot parameters. So you used to do model dot parameters, model dot named parameters, things like this. You can just do self dot parameters and define your optimizer here. Let's say it's I don't know, torch dot optim dot optimizer, sorry, Adam, let's say, and you say self dot parameters, return opt. So now we have our optimizer using the fetch optimizer function, scheduler using the fetch scheduler function, and we have our forward function. So now what we do is we are missing one more thing in fit. So we say self.optimizer is self.fetch optimizer, and similarly we say self.scheduler is self.fetch scheduler. So this thing you need to take care of. Other than that, I think we are probably done. And now we have defined our model here, which inherits from our own class, the model trainer class. And then you do whatever you want, like M is my model, and whatever. And you also need to define the dataset class that I have not shown you here, but you can define it easily. So you have, then you can do m.fit train underscore dataset and batch size, whatever 16 device equal to CUDA, and it will train your model. And it's as simple as that. It cannot be simpler. There are a few more things here that you have to know about, and I have not explained them in this video, and I'm not going to do that. I'm going to go through Thales, and I'm going to show you the model class in Thales and what it has. So I'm just going to go inside model and model.py, and it has a lot of things, but it's super simple. Nothing complicated, lightweight, still customizable. One more thing that I forgot to tell you, let's say you are not happy with train one step or train one epoch. You want to add something there. So what you can do is in your model, you can just write train one epoch. What was it? Dataset or data loader? Data loader, and train one data loader and device self, and you can write however you want to handle it, doesn't matter, and it will replace the train one epoch function. So you write one generic one that works for 99% cases and then you just replace it for the cases it doesn't work. You can also include keyword arguments in here. So now I have a lot of things here. I have the train loader, I have the valid loader, optimizer, scheduler, step scheduler. So this is something that I've added, like I want to step scheduler after a batch or after an epoch. So I also keep track of current epoch, what is the current training step, valid step, some state about the model, the state about training, and I also have a callback runner. So I define a property. I say this is a model state, and then using the setter, I say, okay, I'm setting the value of model state using to something else. You can also do something like, okay, after you set the value, and if the value changes, you can run some code, and that's how callbacks are made. I'm not going into details of that in this video. So I also have something very customizable, which is called monitor metrics. So you can add as many metrics as you want, and after every epoch or even after every step, it will give you the metrics and you will be able to see them. And most of the things remain the same. I have predict one step for testing purposes. So let me show you a code example using this. Let me show you multi-class classification, text classification. So let's go down here. So in this data set, the BBC text data set, I have a category column and a column with text, and our job is to build a model to predict the category given the text. So what I do is I convert them using label encoder, convert the categories to integers, and using label encoder from scikit-learn, and I split them in a stratified manner. So then after that, I have created df train and df valid, and I have a dataset class, bird dataset. So let me go there. So bird dataset takes text and target. It tokenizes it. It has a tokenizer, and it has some other parameters. I don't care about that. And then it returns the total length of the dataset and the simple get item function. So now this is important because your get item function should just return a dictionary with data types, because that's what is not handled in the trainer class. And then I define a model. So here I just import from Thales.module I just inherit from taste.module. And here I have the BERT model. I added some dropout, I have linear, whatever. I have number of training steps as another argument. I have number of classes. So I can change the model depending on the number of classes. And I just say, okay, step the scheduler after a batch. I have a fetch optimizer function that returns Adam W optimizer. A fetch scheduler function that returns get linear scheduler with warmup. Takes self.optimizer, self.num train steps. I have a loss function for cross entropy loss, and my metrics monitors accuracy. So it will always monitor loss, but you can also make it monitor anything you want. And then the same old forward function. Now the forward function here must return three things: output, loss, and the dictionary of metrics. If you do it this way, you don't have to do a lot. And this is not a lot of code. And this is still the same kind of code you would write for if you were just using PyTorch without any kind of helper trainer. So, and you can see this code is Pythonic. It doesn't look ugly. So you have the train dataset, you have the valid dataset, you define the number of training steps, you create the model here. So I've created the model here. And then I told you I added some callbacks. You can create your own callback. It's super easy, and all that inspiration comes from Keras. And then I just fit the model. So I provide training dataset, I provide valid dataset, blah 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 blah. And I also added if I want to use FP16 for training, and when I save the model, it saves the model as usual. And then I have the predict function, which is a generator. So you can do all kinds of post processing as you like. Like I have early stopping. So if you remember this from Keras, you can do train underscore accuracy or train underscore loss or valid underscore accuracy, valid underscore loss, or whatever you want. So whatever you have defined. So yeah, go through this code. If you like it, don't forget to star it. And if you have any questions, let me know. I'm still developing this. It's in very early stage, but I'm telling you one thing. I'm going to be using this for all my future videos, which are not building complicated models, just to save me time. I have already shown you how to design a simple trainer, and I've designed a very simple trainer. And I hope you design your own trainer too. So thank you very much for joining me today. If you like the video, do click on the like button. If you have any comments, let me know in the comment section. If you want to request tutorials for future, let me know. And we will see each other soon. Bye.